Hi, it's Gadget UK here again. I'm sorry it's been so long between part 2 and part 3 of this series. I've just had too many other things that sort of demanded my attention, really. I don't think this will be the last Archimedes video. I think we'll be visiting or revisiting the Archimedes again in the near future. I'll try and summarise at the start of this video what I'm going to be covering. We'll start by looking at voltages. That's something I should have done really in part 1. Well, it was, it's powering up, and something's powering up and it's working. Generally, you don't. It's not the first thing you would think to go check the voltages, but you should check them anyway. I managed to pick up a mouse, as I'll show you in a minute. In part 1, I think it was, we made a mouse adapter there to adapt an Amiga or ST mouse. But nevertheless, there's nothing beats the convenience of having an actual 3-button mouse. I'm going to cover a little bit on installing games onto a hard disk, running them via ADFFS. A little bit on the compact flash side of things, setting it up, how to get the best out of it, how to use a PC to help you with that. There's a bit later on about getting the hard disk LED working on the front properly as well with the IDE board that I'm using. We look at the Scart cable, because that needs a mod. A Scart cable with one of these won't turn your TV on properly as default. You won't be able to get an RGB picture, but I managed to work out a mod for that. A bit of an overview of the chips later on in the video. A quick look at a possible audio mod you can do as well. Later we'll look at some games, and finally just clean up and test, really. So the other thing you should do early on when you get one of these is measure the voltages actually before you start doing anything, really. So we'll do that now. I didn't do that because I'd seen it tested, on the eBay advert there. I saw photos of it powered up and stuff. I knew it was working. But if we just use a common ground there, I've got the meter set on 2 volts DC. So you can measure the 12 volts super easy on the back plane there, but it's just the yellow connector. So the one down there you can measure pretty easy, the spade connector. So you can see the +5 there. I'm just measuring that off the red spade connector on the back of the bridge there. And then the final one is the -5, which is down there. You just have to trust me, I have measured it. I measured it when the back plane was out earlier. But so yeah, our voltages are okay. So as you can see, I got an actual 3-button mouse for this. This is manufactured by Logitech. It sounds like there's a loose piece of plastic inside, but I've been using this, it works fine. So I'll clean it up. What we can do with this is just retro-bright it. So I'm going to get some blonde. It's a form of H2O2, hairdressers use it. And I'll clean it up first in the sink with soap and water, and then I'll just brush some of that on, just leave it out in the sun. It's pretty sunny today. So I've taken all 4 screws out. Let's just take the ball out as well, I think, if we just rotate this. There we go, that's the ball. There we go, it's clipping apart. And there's not even a screw inside to hold it together. You can see that spring's just come out there. I think that's perhaps, I'm not sure where that goes actually. We'll have a look at that in a minute. Oh, there's another one there, I think it's... Yeah, I'm not sure what that is. Those 2 springs seem to hold the board up inside. But anyway, so we better not lose those. But the main thing is we can obviously, clean up that PCB, get some IPA and a toothbrush, clean that, that's pretty dirty. Bit of plastic there, I can glue that back on wherever that's come from. So I'll just keep that little bit for the moment. So we're all cleaned up there, and as I say, all I'm going to do is get some of this on and then brush it around. Because it's super sunny, it should hopefully work quite well. Going to need to do this obviously a couple of times, a couple of coats. So whilst the shell is retro-brighting, we'll just use a cotton bud to initially clean this board. I will go over it with a toothbrush in a minute, but I want to get all the dirt off it first if I can with the cotton bud, because it's going to collect a lot of that dirt that's around the ball area there. We'll go over it with a toothbrush here, some IPA. And we'll have a go with the cotton bud on this side as well, because again, it's still very dirty. Wonder where this was actually used. Was it used in a school or a college or a personal, PC, Archimedes at home? And I'm going to gently clean around here actually, because as I say, sometimes these sensors get bits of dirt in there. Now you can't get to the one on the inside there, because in theory I think there's 2 pairs. Yeah, there is. You can see like a pink one on one side and a clear one on the other. We can only get to one of the ones on one side. You've got to be careful not to move the plastic piece there. Well, that was a bit of plastic came off then, it wasn't it? It was a bit of dust. But this is exactly why I always clean them this way actually. So we'll clean inside the cavity here to start with. It's not too bad. Someone has actually maintained this by the looks of things. Certainly from the outside, they haven't been in it. So the next thing is just clean up these wheels here. It's a case of rubbing the cotton bud sideways as you try and rotate it. Sometimes these are super scratched up, the little wheels there, that makes the connection with the roller ball. And at the end of that, you can see why it was worth doing that. Can you see these giant black pieces of fluff? It's like skin, fluff and dust and stuff that's just built up within the mechanism. So as you can see, we're almost there. There's just some little faint yellow streaks on this. So I'm just using the last bit of the peroxide I've got here. I've ordered another tub actually, but it should be just enough just to coat this, I think. The sides and things are okay, it's just the top really, more than anything. And the underneath doesn't really need anything doing to it really, it's pretty done that. So I'm going to reassemble the mouse now. You can still see, I don't know whether it's going to come on the camcorder, in the light in here I can see little bits of yellow, but when the sun's not going down it looks super white. I've given it about 7 coats, it's just getting crazy the amount of times I'm having to go over it, so I think that's a lot better than it was. So you can see the 2 pieces of plastic that broken off, there were little supports that go there, and these mysterious springs, as far as I can gather, they go over each of those like that, and then the PCB goes in, I'll show you, and it kind of just adds a little bit of springiness to the underneath here where the ball goes. I think that's what that's for. I can't see anywhere else those would go actually. So if we get this back on here now, yeah, there we go, that's clipped in. Yeah, and it kind of springs them down. Yeah, there's a bit of tension at the back from those springs. So the screws I've previously cleaned up, can you see that with the fiberglass pen actually? They've come out really well. Super shiny and looking like new, so turn it the wrong way, wait for it to click, and then turn it the right way. So I've got no guess as to how long the little bits of plastic in there will stay stuck, because I did find them quite hard to glue down actually. It's that kind of plastic that doesn't want to super glue. So the front ones are a little bit more corroded perhaps than the back ones were, but overall I think it's come out really well, this mouse. And it was only £15. That's the thing, you buy something that looks awful like this did, you'll get it a lot cheaper. They're selling the same mouse as this on eBay at the moment. It's 50 quid, which is crazy, because all I've had to do is buy some peroxide, a cost of about £4 for a little bottle. This stuff, that does the job nicely, and as you can see, we've got an almost new looking mouse and it works perfectly. So as you can see, I stripped the keyboard shell down just using a brush here to go between these ridged pieces of plastic here, because there was tons of dirt stuck in there. So as you can see, I took the board out again. Now it came out super easy actually. When you don't remove all the stuff for the drives and things, and you just remove all the connectors, remove the back plane, remove the 2 screws at the back, the 2 underneath that hold it, the ground strap, it just slides out straight away, dead easy. So it took about 5 minutes to get the board out, which yeah, I'm pleasantly surprised with actually. And the reason I took the board back out is to do an audio mod to this. Now it'll be easily revertible. All I'm going to do is remove the LM324, socket it up here. So this is the audio op amp. There's 4 op amp channels in there, and I think it's used for the obviously the audio going out left and right. But the second stage of the the second 2 channels there are used as part of a filter. So there's different ways of getting the audio out of these. Now I think on the PL2 connector down here you can get unfiltered audio, and there are some jumpers here, so I'm going to inspect on the service manual for this, or not really the service manual, the operator's manual or whatever for this in a minute, to see if there's any way to bypass the filter using jumpers. I don't think there is. You might have to do a mod to do that, but I'm not going to do anything with regards to cutting the filters out other than if it's configurable here. But I'm going to swap it with this Burr Brown OPA 4134, I think it is. I'll stick the part number up there because I can't quite remember what it is at the moment. This is something that Zarkos suggested. He's got a YouTube channel. You should go and check out his Archimedes videos. He's got loads on there. He seems quite knowledgeable, but he's done this mod previously and suggested this is something I should look at. And when I read into it, initially I thought I was a bit a bit sceptical, and I thought actually let's have a look at this. And actually there is a big difference. The LM324 has got quite a limited range and frequency handling. I think it has a cut-off at quite a low frequency, whereas this goes very, very high. It's got a much wider spectrum, if you like, of frequencies it will handle. It's not got the same cut-off. So all of the things with the Archimedes, especially with the filtering as well, it's very bassy. You know, you lose a lot of the high frequency stuff. So it'd be interesting, and I might be able to do some side-by-side captures, because this will be socketed. I can just swap, you know, toggle between this chip and the 324, and we'll perhaps do a side-by-side comparison without altering any of the filtering stuff, and just see what the difference is. So we'll have a go with the Solve Station. The legs have been cut super short on these chips, actually, so yeah, that can make it a bit challenging to remove these. Yeah, the solder's come off there, but these are very short legs. There we go. Yeah, so you can see how much the legs have been cut off that. Actually, they're super short. And for that reason, I'm going to fit a turn pin socket, actually. Obviously, I'll clean the solder off there, but then that should mean I can plug that back in without any issue at all. As it is, they're just too short for a dual wipe socket. It's difficult for me to do at this distance. I'll need to re-go over some of these in a minute, I think, just to get equal size solder points. I can't really see what I'm doing from this distance. Just clean up with cotton buds and IPA, and I'll toothbrush with IPA as well in a minute, just to get that looking super clean. But that concludes that short mod. And the main thing is, like I said, this is easily revertible. I can just plug in the 324 back in there and it's stuck. But I'm hoping, like I say, what we can do is you can tap off the unfiltered audio from the PL2 connector there, I think, by the looks of things. So we'll plug the interface in now, and we just need to line it up with the slot there. Let's just move that out of the way a minute, and then just carefully push it in. There we go, that's in nicely. Now this is going to flap in the breeze. I could either chuck it down that way, or, you know, I don't know. Under here is that okay? It's isolated, and there's some tape under the thing itself, the adapter. So actually, I think I can get away with just chucking it there. It's not going to move anywhere now. You know, it's got limited area it could move there. But yeah, I might need to think of some better way of mounting that. So I fitted my AA batteries. And before I forget, some of the earlier models of the Archimedes here, they may have had I think they had the port here for the pod dual bay, but they didn't all have this back plane. So that was like kind of like an optional extra or something you had to buy, and I think there were some third-party ones you could buy. So just bear that in mind, you know, if when you're looking for a particular model to get, certainly some of the early ones like the A300, etc., that range. Just have a look inside if you can before you buy it, just to make sure it's got support for a back plane, or, you know, just check it out, because, you know, it's something worth thinking about. If you want to add an IDE disk to a system like this, you want to make sure you got the relevant pod duals and ports there, you know, on the back plane to be able to do that. So when booting back up here, I had no video. I had to hold down delete because obviously it's lost all the CMOS settings there for having the battery disconnected, and obviously it's lost the hard disk because it's not aware of the pod dual, you know, the configuration that's related to that in the CMOS that, you know, initialises that pod dual when it boots. So I can show you the commands and things you use to enable the drive again. So if I get a command window up, so you can see the command prompt there. We need to do configure ZIDE FS disks, and then you've got to specify the number of disks. And the other command is ZIDE FS drives. X is the number of drives, so one drive. 4. Oh, get rid of that. And finally, one more configure, and I guess this is to do with buffering. ZIDE FS dir cache 32. And at this point, I think we can probably redo a reboot. I'll try a control break. Yeah, that seems to have worked because I've got an IDE disk there, I think. Yeah, that worked. I'm just going to switch it off and on because it didn't come up with the ZIDE stuff actually on boot, which is a bit interesting. I'll see if I can get the full screen on so you can see the top there. If you just watch up here somewhere, previously it was coming up with the ZIDE stuff there. See, it's not doing. Which is a little bit strange actually. I'm not sure why that's coming up silently. But if we go to the IDE disk down here, that is actually working, so that's a bit strange actually. So I'll quickly go over the chips here and a bit of the history and stuff. I'm not going to go into too much detail. You can see here we've got the ARM chip here. It's marked down there ARM. Obviously it's a VLSI device. They manufactured it, and obviously it's copyright Acorn. Now originally ARM was designed by Sophie Wilson, who worked for Acorn on the BBC and stuff. So when they wanted to move on to a new platform from the old 8-bits, everybody else was looking at 16-bit systems. They looked, I believe, at the 16-bit stuff, you know, things like the 68,000, and decided that the performance and cost and stuff was a bit prohibitive. The market offerings weren't really what they wanted to go with. So they completely skipped a generation, went straight to 32-bit. And, you know, as I say, Sophie Wilson designed the, sort of started to lay out some of the instructions and things for this new processor, the ARM processor. Now, I think what they did then is they pushed it as a module for the BBC, you know, a sidecar type thing that you could connect up to the BBC via the tube interface and run the ARM as a co-processor on the BBC Micro. So that was where things kind of started, where they started prototyping, and they used that, the BBC, I think probably the BBC Master, and the ARM co-processor there to develop the chipset to go along with this. In its first, sort of computer incarnation, where it would become the ARM2. And as I said, they designed the other chips that you'll see on this board using the original ARM processor. So yeah, quite clever the way they did things. So this particular one runs at 8 megahertz, and performance you get around between 4 and 4.5 MIPS. Now MIPS is one of those things that I've always thought was a bit odd, really. It stands for million instructions per second, and it's kind of a benchmark that they use for CPUs to determine how good or bad a CPU is. And it's not really a true reflection on how good a processor really is, because all you're doing is coming up with the number of instructions that it can process within a second. And even though some instructions on a certain processor might take a number of clock cycles, that could be advantageous, because on a device like this you may need a large number of instructions to achieve the same thing. You might even need more instructions to achieve the same thing. But nevertheless, that's how they benchmark things. Now, if you compare to, say, an Intel 386 running at 16 megahertz, that came out at the time around 2.15 MIPS. So, believe it or not, this was, in terms of MIPS, is faster than a 386 running at 16 megahertz. And obviously the same sort of thing holds true of the 68,000 as well. For example, a stock 8 megahertz 68,000 like you get on an ST is a bit slower than that on an Amiga. Actually, it's something like 7 point something megahertz. You get around 1.5, well 1.4ish MIPS. So this is actually you just perform an awful lot faster than a straight 68,000. And even if you look at a 68020 running at, say, 16 megahertz, you'll get almost 5 MIPS out of that. So you can see, this was a super performing processor, really. It's no wonder it's took off the way it has. And you'll find ARM processors, well, obviously newer versions of the ARM processor, it's had a lot of different iterations over the years in lots of modern devices, and I'll perhaps show some of those in a few minutes. So as I mentioned in the previous video, this is a RISC processor, reduced instruction set. Versus complex instruction set, CISC. So your 386, for example, is an example of CISC. And in layman's terms, the difference between RISC and CISC is, well, the first thing is obviously a reduced instruction set. So you've got a lower number of instructions on a chip like this versus a 68,000 or a 386. Typically, on those other chips, CISC chips, you'll have many more instructions, but lots of those instructions take a number of clock cycles. If you've seen the Noob's Guide to Digital video I did there, where you've got the clock pulsers, coming along and rotating gears and things to move various pieces of functionality, that sort of analogy, you've got a similar thing where, you've got a pipeline, if you like, of the different components within the processor. And with an ARM processor like this, this RISC processor here, it's been simplified so that you've only got simple steps. So instruction comes in and the instruction gets processed, that's it, it's done, like in a single clock cycle. Whereas in the CISC system, you might have a number of clock cycles required to push the data through the different steps, the pipeline within there, in order that it can actually do all the individual steps. It could be 3 cycles or 4 cycles versus the one that you would typically get for most of the instructions in here. A misconception is it's all about, the reason these are faster is just because it's got a very few instructions, but it's not really that. It's actually the fact that the instructions have been reduced in number, the quantity of them, but also the structure of the instructions as well. On something like a 386, for example, you've got many different modes of operation where, for example, one instruction could have 4 bytes, another one might have 3 bytes, one could have 2 bytes, and all of that complexity there needs, a number of clock cycles in order to decode those instructions. Whereas on something like this, they've simplified it, so you've got 4 bytes, per instruction, a consistent structure there. You can have short versions of some of the instructions, I think, that might be 1 or 2 bytes or something like that, but again, it's been simplified to make it optimize that process there of decoding the instruction, process it, decode it, process it, all within a very short number of cycles, ideally 1. So coming back to the fact this is an ARM2, this was the initial launch version of the ARM processor in these systems, 8 MHz. They later went on to the ARM250, which is in some of the new ones like the A3010 and A3020. Now the ARM250 was what they call a system on a chip, so it's a larger chip than this, it's got a large number of pins, and it consolidates the chipset here, so you've got the memory controller, the I/O chip, the VIDC, all within the ARM250 processor. So the difference between this and the original ARM processor in the BBC, the tube interface there, is they added the multiply instruction into the ARM2. And that's kind of a really nice to have, because without that, you need probably a series of instructions to get the same thing. If you want to do a multiplication, I don't know, it could be, you might need 6 instructions or 8 instructions running through here to get that multiply, or even more. It could be quite a lot of instructions, whereas with the multiply, it might still be more than one cycle on here, but the net result is it's a cost saving. So they did add a multiply into the ARM2 here. Now the ARM3 that followed this, and incidentally you can fit an ARM3 to this piece, this board here. You remove the chip and you get a little carrier board that just plugs into the existing socket there, and obviously it changes the pin out a little bit. There's maybe a few components, a transistor or two and a few diodes or something on there just to deal with some differences, and you can fit an ARM3 processor on here. That might not be the case with all the models, it's going to vary, but I do know you can do it on a 440. Now the ARM3, which came in some of the later models, obviously that runs even faster, but they had 4K of unified cache on board as well, and I think they added a couple of swap instructions or SWP instructions as well. But for the most part, you'll find that most of the software is quite compatible between all of the ARM processors there. Obviously there's going to be some software that's been, it makes use of a specific instruction or it needs that cache, etc. It's probably unlikely. But for the most part, you'll find that some of the later games and things still run on this fine. Chaos Engine's one of them. You'll see, we'll play that in a few minutes actually. It's, I think the disk images are, the HD high density disks, which this can't support without a mod. And I'm guessing it's because obviously it was targeted at some of the later models that had a HD drive, but it does run really well on here. It's perhaps not as fast as it would be on some of those newer versions there that perhaps got an ARM250 or an ARM3, but it does run very well. So a quick look at some of the devices I've got here that have got an ARM processor, DS Lite, Game Boy Advance, GP2X. Some of these it's more of a system on a chip, certainly with the GP2X, 3DS, iPhone, probably other smartphones and things as well, and tablets, iPad, etc. But also the Nintendo Switch, the Ouya, and what's it called, the 3DO. So Arabella is the VIDC chip, that's what it's called. It's actually the video controller, but also provides the sound as well. And as I mentioned a few minutes ago, in the later models that use the ARM250, this is merged with the ARM250. Now you can get a mod for the VIDC here that basically tidies up some of the signals, I think, tightens the time in there to give you better support with the VGA monitors and stuff, but you can also overclock it slightly using that little board there. I forget who makes it, I'll stick a link up top here or something. But you can also, overclock it there and get Super VGA support, like 1024 by 768, etc. I mean, obviously your colour count gets reduced. The higher resolution you go, your colour count goes down. But you can get 256 colours in many of the lower resolution modes here. It's quite a capable little device, really. In some ways, I like to compare this to maybe to the 1200, the AGA chipset. It's perhaps not quite as good as the AGA chipset. I do know that the 2D performance on the Amiga 1200 is better generally than this system. But this system really does beat the 1200 in terms of raw calculation, performance and stuff, and on the 3D side in particular. And the VID-C chip obviously was marked Arabella, that was like a code name, and you can see this is the IOC chip, it's an IO controller here, and that's marked Albion. And again, if you've got the newer version, a 3020 or a 3010, you're going to have an ARM 250, and this is merged within there as well. While we're looking at the board here, I'll just point out there are lots of these tantalum capacitors here. You see this little orange one? There's loads of those. These are renowned for short-circuiting when they fail. So, if you get one of these and it's not booting at all, check your voltages. If you're missing a voltage, start going around checking these tantalums. You can generally tell with these, you can feel them. They go super hot, obviously, because they're just, they kind of just short out the rail there. So just coming back to the Ethernet connector here, you can get the RTFM joystick interface that plugs into here. It uses these two connectors, which I guess is okay. For home use, you're probably never going to have an Econet fitted, but you could then use that for the RTFM interface. I've not seen any schematics for that. It looks quite a simple device. It looks like it's got 3 TTL chips on there. So if anybody's got one of those, please let me know if you could, maybe take some close-ups, photos of the top and the bottom side of that board, because I could then just design a PCB and we could remake these and offer them out to people and stuff, because it'd be nice to do that and add a joystick port. Obviously you need to remove one of the back planes for the pod dual thing there to connect a joystick port up or something, but yeah, that was one of the types of joystick you could get in the early days. But you can also get, I've seen joystick interfaces I think for the parallel port and the serial port too, but again I can't find any information on those, how they're wired, whether you could create one yourself, etc. And I haven't seen any for sale at all. Super hard to find. So just bear in mind, if you want to use a joystick with an Archimedes, you want to look at the newer models like the A3010 and A3020. As far as I understand, the only difference between 3.11 and 3.10 is this fixed a serial port bug. But there might be other differences. That just seems to be what seems to be published there on the internet. It all seems to relate to serial port bug. So strictly speaking, I might not have needed 3.11, but I went to 3.11 because there seems to be a lot of things that seem to require 3.11. I suspect they probably work on 3.10, if I'm completely honest. And again, in some of the earlier models, you've not got the same 4 slots here. You might still have 4, slots for EEPROMs here, but they might be slightly shorter. I think you needed a carrier board. Depending on what model you've got, some of them you need a carrier board that plugs into the slots there and then expands to give you, the relevant number of pins to stick this size of EEPROM in there. They were perhaps designed for smaller chips originally. Originally, this would have come with Arthur. I think Arthur was the original operating system name. The colour scheme they had there as default was awful, actually. It really was. And it wasn't very popular, Arthur, to start with. But by the time they got to Arthur version 2, I think, they renamed it to RISC OS 2 and changed the look and feel and stuff of various things. And obviously, it was a lot better to do with the multitasking side of things and stuff. And at that point, it became quite popular. By the time you got to RISC OS 3, it was super popular. And in fact, I think when I was in the trade, we had a couple of machines came in originally with Arthur. I remember working on those, but later they always seem to have RISC OS 3. So in order to get ADFFS on here, on the PC I used an Archimedes emulator. I forget the name of it, I'll stick it up there. And I installed ADFFS. Now the zip is about 3 meg or something like that, I think. So I was able to copy it into a folder that the emulator can access. I think it's called the FS, there's the name of the folder. And that appears on the desktop down here as like an extra drive on the emulator. So I was able to install it that way. But then I've got the challenge of using 800k disks to copy across like roughly 3 mega data or 2.5 mega data. So I ended up splitting it into 4 disks, and the way I did that is I went into ADFS. I'll just show you. If I go into the folder there, so you've got this single icon here, and if you hold down shift double click, I went in here and I copied into 4 different ADF images, disk images, the various chunks of files there. It was a bit of fiddling because trying to get each disk up to almost capacity, it was a bit of trial and error, but I did that, split it, copied them onto floppies, copied the floppy, put the floppies in here one by one, copied the files over, and then merged them all back together into the correct structure. So it was an absolute nightmare. I would suggest if you're going to get one of these systems, the easiest way of getting files from a PC onto here is with a zip disk. You remember one of those old zip drives? It's like a magnetic optical media. Is it SideQuest or someone made them? I can't quite remember now. I used to have a SideQuest drive myself, which is a very similar thing to the zip drive. But anyway, they're about £100 each, and obviously you need something you can connect to your PC, something you can connect to the ARC. Now you could get a parallel port one. That means you need an old PC with a parallel port or a parallel port interface for your PC in order to plug that zip disk drive in there. Copy your files on there. I think they're about 120 meg those drives. They're quite big. They might not be quite that big, but yeah, they're pretty big compared to a floppy. And then obviously you could use the zip drive, connect it up to your Archimedes parallel port, run the software, extract, copy the files across, do it that way. So you could get away with one zip drive, but logically you're going to need one for the PC, one for the Archimedes, unless you want to keep moving the drive around all the time, because that would be a trial. And at £100 each, and then there's the discs are about 20 quid each or something, and it's old technology. Is it worth it? So yeah, I struggled getting ADFFS across, but now that's there, it's pretty easy to install the apps and stuff for the games. So I'll show you a really simple example now. This one is going to be a single disc one, and all I've got is a 720k formatted floppy, and on the PC I've just copied across the disk image from the ADFFS website. So this is a single disc here for Populous, and we just need to copy that somewhere. So I'll stick it here, we'll rename it in a second, so you can see that's copied across. But the nice thing is, because most of these disk images you find are smaller than 720k, you can fit them on a standard PC format 720k disk, and the Archimedes will read it. So that's a really super quick, easy of getting a single, one of these files across here between the PC and the Arc. So that file's on the hard disk now, you can see that, and what we want to do is a couple of things. First of all, let's rename it. Let's rename it to Populous. Hang on. Yeah, common mistake, I forget you've got to scroll across, keep the cursor there, and then just type it. There we go, Populous. And we also need to right click on it, and I say right click, I'm middle click, and set the type there to floppy. As soon as you do that, its icon will change to the ADFFS icon. So if we now start ADFFS, wait for the icon to appear down here, I think. There it is, and we can double click on the Populous icon, and that's going to mount that as if like a virtual disk. And there we go. So you can get, obviously like cracked versions of these games on floppy, but then they're an ADF format. So you've got to write it onto a floppy, and then you're going to only be able to use it from the floppy, unless it's been cracked in such a way that you can just copy all the files from the floppy to a folder on your hard disk. So it's a bit fiddly, but ADFFS is really nice in the sense that it's a bit like WHDLOAD for the Amiga. There's some effort gone in there by the author. Is it John Abbott? I think it is. I'll stick his name up here. Yeah, major kudos to him, because there's nobody else doing this. He's working his way through the library and archiving them in such a way that they can be, played this way from a hard disk. And often you can play them two different ways. You can actually, just mount the disk and run it, and then use a keyboard combination, Shift, Control, and I think F1 for disk 1, F2 for disk 2. And the file names are critical if you want to load a multiple disk game that way. So for example, let's say Lotus, for example, you see I've got a couple of folders there. Ignore those need deleting really. But if we're going to Lotus 2 folder, for example, you see I've just got one set of files there. I've merged them all together, so you can, some of them, there's instructions to do this on each game. So you can run from hard disk, or you've got the original disk images here. And this is where the file name is critical. You've got to have that, there's an F code each game has got. In the original file name you'll see it, but by the time you've copied it across and renamed it, you'll have lost that. But you've got to have those, the F, it starts with F and then there's a number. So if that was F, I don't know, 1604 or something, that'd be 1605 or whatever. And then when you launch this game, when you press the Shift Control and F2 to get disk 2, it knows to look for that file name, if you see what I'm trying to say. So you need to bear that in mind. But for single games like this, Populous, no problems at all. And as I say, you can there are instructions in each game to merge them together. I'll show you how I did Heimdall in a minute. That's a 5-disc game. So rather than me manually having to keep pressing Shift Control and F whatever when it keeps asking for the different disk numbers, I've gone for a hard disk install, and that's the beauty of the way that John's set up this ADFFS. And it's dumping, he's been dumping the original disk with the protection and everything, and in places bypassing that protection in order to get these things working in a nice, easy to access way. So let's test Populous. Double clicked on that. So we already clicked on Populous there, and obviously ADFFS needs to be loaded first, and there you go, it's given us our little virtual floppy here, and we can just simply click on Populous icon, and there we go. Sweet. Fantastic. I love this game. This is one of those games where you really do need to use a 3-button mouse. I'm using the other mouse at the moment because I'm retrobrighting the new mouse I've just got. So this is one of the more complicated examples of how you install a game that's got multiple disks using ADFFS. Did I get an extra F there? I'm not sure. What you've got to do initially, the same thing I've been doing here, is using a PC 720K formatted disk, extracting from the ADFFS archive for that particular game. So Heimdall's got 5 disks in there, the disk folder within the zip that you can download from the website. Again, the links will be above. You unzip the individual disk images onto the floppy one at a time, so it's painful. I've had to copy across each one of these. You can see I've got Heimdall 1, 2, 3, 4 and now 5. The 5th one's just finished copying across, so we'll close that. I've created a Heimdall folder, as you can see here, so we'll just move that, if I can, up here. I'll take the floppy out now. I'll just eject it, doesn't need to be in there. So if we load ADFFS, wait for that to appear down here, there we go. So now we can actually mount these if we just double click on them. In fact, you actually need to set the file type generally to floppy, but these are, I think it's kept them, it's automatically from the zip, it's automatically identified due to the file extension. These are of the type floppy, so I can just double tap. So I'll go into the first one. So this is the first disk, Heimdall disk 1. Wait for that to show the contents. I think they're compressed, that's why it takes a long time here. There we go, so there's the contents. So what we can do is, I think on the guide it says just copy Heimdall, and then we modify it, then we copy the 0 folder. What I'm going to do is just select all, copy everything into our folder there. And I'm going hard disk to hard disk here, obviously the file's already on the disk, so it's a lot quicker. So that's the first step. Then go into the next disk. And I believe what we need to do is just copy the numbered folders. So each one of these disks here will have a folder. So the first disk got a 0. Disk 2's got a 1 folder, I think. Disk 3 will have a 2 folder. There you go. And we just copy the folders into here as well. So we're getting there. We're on the last one now. This is on disk 5. There's a folder 4, so copy that across. So yeah, you can just about see up the top here. We've got folder 0, 1, 2, 3 and 4 now. So we'll close that. We'll close this, I think. So there's our folder. The next thing, some of these have got a document inside there. You can see it's got HD installed. If we double tap on that, it's I don't know, that's the original instructions. I know it's not. Yeah, that's the instructions for this, so we can expand that. So the next thing we need to do is hold Shift and double click the Heimdall, and then Shift, double click Run. And we need to edit this script. And these instructions are on the ADFFS website actually, with the game there. So it's not that you need to work out this stuff yourself, it's already there. Replace run with the contents of adfs.obey. So there's a script here, so we need to go find that. So let's just move that down a little bit. What I need to do is load Sparkplug. Let's just do that. It's in my utilities folder. The reason being is what we need to do is we need to copy the contents of one of the obey scripts. Cancel. So now if we shift double click into ADFS, scroll down, find the obey. See, look, it's changed the icon there. It's got a blue icon now. It didn't before. Into here. That should open it up as a folder, I think. Yeah, there we go. I need to find the script that relates to this game. So the one I'm looking for is F1018801. There it is, F1018801. So we need to copy that out somewhere, so let's just copy it here temporarily. Right, so this one's been particularly painful. The run file, what I did is I saved that other script as exclamation mark run, and copied it in there. You can see this is the one that the contents of that obey script. So if we go back out, the other thing I need to do is in the Heimdall application folder here. This is where we need to stick these 0 through to 4 folders actually. So I'm just going to one by one copy them in there, then delete them from here because they're in the wrong place. I think I stuck them in the wrong place. They need to be within there. Right, so I think we're finally there. So if I just close all these other crazy windows here and we just look at the Heimdall folder here, if I shift double click into that, you can see I've now got 0, 1, 2, 3, 4 which came from the individual disks. We've modified the run script there, copied it from the obey file which is contained in the ADFFS application archive, whatever the hell it's called. So I think the only thing we need to do now is load ADFS or ADFFS. I should put an icon down here. That's it. Close those and just double click on that icon, and fingers crossed that should now load. Not sure I was stuck on a white screen. Oh, it's doing something. I've skipped past it. Do you want to skip the intro? No. So yeah, that would appear to be working. Sweet. Sorry, there's a huge light glare there. So if you remember in the previous video I said I'd ordered an RGB lead. This is what came, Scart RGB lead. Now bear in mind I already had the lead to connect to the 1084 there that I made in the previous video, but I wanted one with a Scart connector. Now this lead works perfectly with the 1084 with the Scart adapter I've got. Doesn't work with my TV. On my TV it comes up saying it's in composite mode and the screen's just black. So I figured there was something going on with the switching, and if you look inside here, the way this is working, that's the composite sync signal coming in here, and it's going across the diode to this capacitor here, and I guess what they're trying to do is ultimately provide a voltage source there to the RGB switching pin, but my TV's not accepting that. I'm guessing it's not high enough. So I think what I'm going to do is remove the diode, remove the cap, connect PP3 up. I'll connect it up to the switching pin down here that we normally feed 12 volts in. Obviously it's going to be 9 volts, and then I'll just feed with a resistor, I don't know, 100 ohms or something, over to the switching, the RGB blanking pin here. So it will automatically switch the TV on via the pin down here. I forget which one it is, it's either that one or that one. I think it's that one actually. And then it will put it in RGB mode, hopefully, with a use of a PP3 battery. There's nowhere else to get 5 volts from. I did consider, connecting to the serial or parallel port or something, and having another fly off from here, another 9 pin or 25 pin connector, but there is no 5 volts on either of those ports there, the serial or parallel ports. There's no 5 volts on the back at all anywhere, as far as I can see. So yeah, PP3 battery. Is it a PP3? You know what I mean, one of them square ones. Yeah, that's the only way I'm going to be able to get that working, I think. So I'm just going to test the switch first of all without having it connected up. Now you can see I'm on X3. And if I connect the battery to the back of the cable around the back of the TV, just go with me, you should see a switch. Watch. There you go. So the battery is working for the switch. So I used a 380 ohm resistor there, and as you can see, it's working. I'll probably show you that in a second, but fantastic. It now means I can obviously use this on my large TVs here without an issue. I thought it would be useful to try and dump the SD card. Now, the one I went with, not the SD card, compact flash card, the one I went with is 128 meg, which is not very big at all actually. And I've probably only 40% filled it so far, but it would be nice to increase the size of it. Now, there are a few options. I think what I'm going to do is take the compact flash card out, dump it on the PC, create an image of it. Hopefully I'll be able to load that in an emulator. And what I can then do is stick the large compact flash card in here. I've got a 2 gig one. We'll format that. I can image that, and using the emulator on the PC, I can transfer across everything I've got so far from the compact flash card that's in here now, 128 meg, onto the new 2 gig one. If that makes sense. So yeah, we'll test that theory. So I'm going to go back inside here now. So we'll find a way to secure the compact flash card anyway, but we'll go and dump it. Yeah, so you can see how I was testing that. I literally just tucked it under there so that, you know, it can't go anywhere. And in fact, you know, it might be safe to leave it like that, but you never know, with a bit of movement it could come out. But we'll just unplug that. And as I say, let's go and stick this in the PC and let's dump it. So I really need to clean this PC. It's looking a bit dusty in there, but if we just plug that in. As you can see, I've loaded Win32 disk imager. I'm not sure where you get this from. It's pretty easy to find. It's picked the device already, Q. It's only show me drive Q, and in the file manager, you know, in Windows 10 here, it's showing that as Lexar. It's a Lexar compact flash card. So we'll give it a file name, darc128.img. What we want to do is read it. So that reads from the device to a file. So as you can see, it's going pretty quick, that, because it is only 128 meg, so it shouldn't take long to test this theory. But the nice thing is, even if we can't read this in the emulator, you can dump these compact flash cards this way. So, you know, if you've got you know, a setup card there with lots of games and applications and things, and you know, you want it, you know, you've got it how you want it, it's a good way of backing this drive up. If anything ever happens, you can just write this to the compact flash card again and you're back as you were, or you can write it to a different compact flash card. Bear in mind, the size, you know, is an issue. You know, so if you wrote this 128 meg image here to a 2 gig image, you know, 2 gig compact flash card, you're only going to have 128 meg, and you need to use some software or something on the Archimedes to, or on Windows maybe, to work with a compact flash card to resize the partitions and things. Sorry, I know it's super reflective, that screen, and the refresh rate's not helping. And if I go down to the hard disk down here, what I'm expecting to see is games, apps, welcome. There you go, that's it, it's worked. If I go into the games folder, there's ADFFS and the arcade games. I go into there, everything's working. So I can now finish setting this up in a much easier way, because, for example, Chaos Engine, the disks for that, you need 1.8 meg disks, or is it 1.6 meg disks, so you need high density floppy drive. I can't get that game across because there's quite a few disks as well, 3 or 4 disks, and it's a similar sort of thing with Alone in the Dark. I think that uses double density disks, but there are about 7 or so disks, and it would take me forever. I keep writing them to disks, going through, you know, in and out the rooms here, trying to, you know, out of one room, sticking it in the Pentium, write the disk, go back into the other room, stick it into the Archimedes, copy the files across. Is painful. So doing it this way, I can finish setting this up and stick a load more games on here super fast, and then we can just write the image back to the compact flash card and stick it back in the Archimedes. But as I say, now we've proven this works. I can also, you know, put a larger compact flash card in there and transfer all these files across without an issue. So just to test that procedure, I installed Chaos Engine there in the emulator, and I'm writing that hard disk image back to the compact flash card now. So we'll give that a test. I mean, bear in mind, I've got a dump of a compact flash card as is. I can get all the files off it, so all is not lost if this doesn't work, but in theory it should work, I think. So I'll show you some games now, and I'll show you one or two other things. Yeah, something I forgot. If you go into the task manager down here, and we scroll down, you can easily, if you see the RAM disk thing there, you can easily just, I think, drag along here and create a RAM disk, which is fantastic, 768K. And you can see it puts an icon on the bar down the bottom here, so you can just copy things in there and run them from there, etc., or copy them elsewhere, and it's super quick. So yeah, that's a really nice feature. I do like RISC OS. I have to admit, as I've played around with this for the last 3 or 4 weeks, I've really grown to love it. It's a really nice operating system. There are a few things that irritate me a little bit about it, like for example, if you go into something you want to rename it, you know, you sort of middle click and then you've got to go, that's the file you get, and you just scroll across, a bit like you do in Windows where you're trying to navigate, you know, to something on a menu. You just hover over it and it expands, you know, you're drilling down. But then to obviously rename, you don't press, you don't click, you've actually just got to, you know, start to type, as you can see, and then press return. So yeah, that can take a little bit of getting used to. So if I show you how much space we've got on the hard disk here now, free 34 meg, So I've used 88 meg with it, and that's got all the games on it that I currently want. But we've got the old drive. I don't know if you can see, I created an old folder there and I copied across that everything from that old disk before it died. Now it's interesting, most of the stuff came off there. There were just a few things where it had corruptions. I think that desktop C, that's a version of C there. There were a few corruptions in there, so I'm going to have to ditch that because it doesn't work properly. WP, that's like some sort of word processor or something. Again, there was some corruptions in there. I just kept this on here just out of interest. I'll zap this probably following the end of this video here. I just wanted to see what was on it. I'm always, you know, it's always interesting to see what other people have had on their discs. I did go into some of these and have a nosy. Yeah, there's a few C files and things that people have produced. There's accounts, their home accounts, and I had a quick look through here. It's amazing. the person who owned this earns more money than me, that's for sure. And has a lot more savings. So I was horrified at how many savings they had. No wonder they could afford an Archimedes back in 1991, 92. But anyway, nevertheless, that'll get zapped. And I'm not going to share that, obviously, for you know, sensitivity reasons. It's obviously someone's financial details. They didn't have much else on here. There was a C compiler there, but some of that files were corrupt. There are a few executables. I'll perhaps keep it later when I've looked through them, some source code. That's an accounts package, I think, a database or something, I don't know. So there wasn't much on the original system. There were a few folders for games, which I kept. The original one there was arcade, and I stuck a load of my games in there. So these are ones that don't need ADFFS. I've just managed to copy them straight from floppy. So I mean, let's load Xenon 2. Now this is it's like an enhanced version. I think there were two versions of Xenon 2. This one's makes more use of the 8-channel sound, so that's one of the nice features. So I've got to click on that, I always forget that. One of the nice features with the Archimedes, you've got 8-channel sound. Sweet. So let's start the game. So I think one of the benefits of this particular version is you've got the sound effects and the music. If you compare to, say, the Amiga version, I think as you fire, you lose one of the sound channels because you've only got 4 channels, haven't you, on the Paula chip there? Is it 2 on the left, 2 on the right? Yeah, so you don't lose the music while you're firing, which is fantastic, really. So you can see it's, you know, I don't know how that compares to, I don't know, when it's running on a 1200, it seems about the same to me, maybe a bit slower. But again, if you had the later machine with an ARM 250 or an ARM 3, it probably runs super well, but actually it's super playable. And the sound and music is fantastic. Fantastic. Anyway, I'll show you something else now. So you can press Control Break there to reset the system. The interesting thing is sometimes things remain kind of resident when you do that. So yeah, just bear in mind you might need to power cycle if you get strange behaviour after doing a Control Break. So I'll quickly load Lemmings. That's worth having a look at. Fantastic port of Lemmings here on the Arc. So again, looking very comparable to the Amiga and ST versions actually. Well, the Amiga version. It's got better sound than the ST version. Yeah, pretty much just what you'd expect of Lemmings. Speedball 2. Sweet. Seems to have more sound effects this version as well. I don't know, I've noticed like an ice cream seller shouting at ice cream and stuff. I never noticed on any of the other versions, so maybe I'm imagining things. It's perhaps not as colourful as the CD32 version, but still, it's very good. It's an excellent version. Yeah, you've got Wolfenstein 3D as well, and it doesn't run bad on here actually. Although I suspect this would be much more playable on an ARM 250 or an ARM 3. Yeah, so you can use the mouse, which is sweet, but you can see, you know, it's just a little bit jerky, I guess, with the mouse. But it's, you know, the full game, you can play it, everything works. It's just a little bit slow on this. Yeah, so if you're planning on playing this, look for one of the higher spec ones. I've got the sensitivity set really low as well, so it's, you know, it's not very quick at rotating. In my ADFFS folder, I've got pretty much the remainder of the games actually, and I've found every game I wanted. I might have mentioned earlier on it's quite hard to find some of these. I certainly did on Twitter. And they are quite fragmented over the internet. You've got to search in different places. Some of them have been packaged up there on ADFFS, on the website there. If you go into the forum and go into the games section, you can find downloads there of ones that are free to distribute and stuff, where John has got the license, to distribute. Okay, but there are some games, like for example, Last Ninja game there, that's hard to find. Some of the ones down here, Zark, that was super hard to find. It was a comment through Plan C helped me find that. It's been removed from nearly everywhere because apparently Superior Software, who own the copyright to many of these games, are a bit fussy and are insisting on sending takedowns all over the place, which is ridiculous because they aren't selling them. You can't buy them anywhere. You can't even buy this. I looked on eBay, try and buy an original copy of Zark. No chance. You can't find it. It's unavailable. And when it does turn up, it's like hundreds of pounds apparently. And it's the same with some of the others. I think you can buy Last Ninja on there. It's like 50 quid or something. I'm not paying 50 quid for Last Ninja. That's ridiculous. It's not a very good game. But nevertheless, people like John are essential, really, and I'm really grateful to John for the work he's done in producing the ADFFS and packaging up some of these games and writing code there to bypass the protection. Now, I haven't done that on Battle Chess. I've still got to get rid of the protection on that, get rid of it on Alone in the Dark. You can do that. It just needs a bit of tinkering. For example, you hold down Shift, you go into there, you replace this run script here, the run obey file, with the obey file from the ADFS folder, holding down Shift again. Down here, you can see there's an obey file, that's actually a zip. So you have to open Spark FS, drag obey into there, that opens up the folder with all the scripts. You copy out the script for the Alone in the Dark and replace the run file inside there, and you can bypass the protection. So yeah, I've got some teething problems trying to work out how to do that. It can't find a path to certain things that are called within the scripts, but trust me, with a bit of fiddling around, if you get stuck on this stuff yourself, by all means drop me a message and I'll try and point you in the right direction. But as you can see, I've managed to get a load of games here: Tower of Babel, Last Ninja, Alone in the Dark, Battle Chess, and Alone in the Dark. That's worth pointing out. It's one of the few of these systems of this year that supports Alone in the Dark. It went onto the PC, but it never hit the Amiga, never hit the ST. Yet here it is on the Archimedes, and it does run very well. It would run better on a 250 or an ARM3. I would say here it's just a tiny little bit slow, but it's totally playable. Cannon Fodder, again, you'll have seen that on the Amiga and the ST. Chaos Engine, I'll show you in a sec. Chocks Away is a nice flight sim there. World War One, fighter planes. Chuck Rock, again from the Amiga. F-Type, that's a nice Jaguar sort of driving game. Fire and Ice, again from the Amiga. Flashback from the Amiga. Gods from the Amiga. Heimdall for the Amiga. And these are all really good versions. They've got really good sound, really good graphics. Hostages, you'll have seen that on the Amiga. Lander, which is a demo of Zark kind of thing, really. What else have we got? Magic Pockets, again from the Amiga. More Lemmings, Nebulous, Pipe Mania, Populous. Quest Goal, that's kind of like a track and field type thing. It's okay. The graphics are a bit over the top, but it's pretty good. Sensible Soccer, Simon the Sorcerer. Again, these should be familiar names of games to you. Terramex, Top Banana, Trivial Pursuit, Zark and Golf, and then Zool, again from the Amiga. And another thing before I forget, let me think what it is. I put it in the welcome folder. There were 2 discs that came with RISC OS 3.1, I think, and I found those 2 discs on the net. And one of them has got a BBC emulator, so you got lots of things here, demos and utilities and things, a bit like you would get with the Amiga. You got your workbench discs and stuff, and it had lots of extras and things. So you've got all that stuff. You've got Maestro, it's a music application you can use to create music. And I'll show you something else on the subject of music in a minute as well. Patience, obviously a game. H-Form used to format hard disks. Bear in mind that the IDE module I've got in here has got a different version, customised version of H-Form that's used for that. But as you can see, you've got 65 hosts. If we run that, BBC Model B emulator. Yeah, sorry, the sun was glaring that out, but can you see BBC Computer 32K? It's fantastic. So I've written some basic there. We just run that, and you can see you can run things in basic. So you can't load the DDS images or whatever they are, the double-sided discs, and I don't know what the extension is now on the BBC, but you can't run those. But you can get, I think, another emulator, 6502M or something like that, which is a bit better. But obviously performance is going to vary. You need a faster RISC machine, really, you know, like a strong arm or something if you want to run things really, really well from BBC that way. And obviously it's got basic built in as well. This is BBC basic here, but you've got the, you know, I don't know, Archimedes basic as well. So yeah, I mentioned that music creation program. You got one of the welcome discs there, but I've also installed something called Cocanizer, which is a mod, you know, a mod tracker. There it is, Cocanizer. And there are numerous ones of these. I think there's several, at least, you know, sound tracker, noise tracker type things, where you can create your own mod files and load mod files. One or two of them will load mod files from other formats, you know, Amiga, etc. So yeah, this should immediately be familiar to anybody who's played around with like noise tracker or sound tracker. The difference on this being you've got 8 channels down the bottom here, which is really nice actually. And using the palette thing down here, you can actually change your screen mode. You can see there we've got different screen modes. So we can put it in 256 colour mode in either of those two. But there are a lot of different screen modes. I'm not sure why only a few of them turn up here. You may need to go into configure to add support for different modes and things. But yeah, those are the default ones. And they all seem to work on the TV and they work on the monitor as well. So for the LED, I think these last two here are for the hard disk. And I've just, you know, you just push in carefully and pull at the same time. You can see those are coming out. So I'll just get a battery. I'll use a CR2032. Just put it across those contacts the right way around, and just make sure the LED, you know, if the hard disk flashes on the front. If it does, I think what I'll do, and it's kind of a bit sacrilege, but there's no other easy way to hijack the connections here. I'm just thinking, what I might do is just snip into the wires here to expose them a little bit. Heat shrink these off, so those will still be there. You could then just remove the heat shrink, plug them back in. Does that make sense? And then on the little bits that are exposed here, again using some heat shrink tubing to isolate, I'll join a pair of wires on and I'll twist them together, and we'll just feed off to the IDE module over there because there's a jumper to connect, and I'll stick a little pin header and join it up. You'll see it should be nice and tidy, and it's fairly easily reversible. Top one is power, the bottom one's hard disk. The positive on a CR2032 is the flat part at the top there, and if we just connect this up, hopefully you'll see that? Hard disk LED is lighting. So we know that that's definitely the pair for the hard disk LED, so I can, you know, do what I've just described. And in fact, thinking about this, rather than cut the sheathing off the wire here, you know, the protective covering, I'm going to solder onto the top here just a little bit and join the wire on, and then I can just heat shrink these up like that. So it's joined on that way, but because you then be able to remove the heat shrink, remove the wire, use a bit of solder blade on a little bit of solder, and those could just then plug back in. So there we go, I've joined them up super carefully, and as I said, that's really easily revertible. You can just plug them back into the red housing there and it'll be okay. And then as you can see, I've just twisted the red and black wires here. I just need to equal the length on the end there, snip a little bit off that, and I'll heat shrink on a connector that can plug onto that pin header there. Right, so there's the heat shrink done. Just put a few more twists in this, I think, actually, just to make it look a bit linear in regards to the twists. Yeah, that's not too bad. I'll show you which way around I've got the LED. I had it on the wrong way to start with, so it was actually on when it wasn't active and going off when it was. And if I load a disk, just watch, see that? Yeah, so it doesn't stay active for very long because it's super quick, the drive actually. I'll load a different disk here. Yeah, you see that was super quick. But like when you're booting this and you're going in and out of folders, you barely see any activity there because it's so darn quick. See, like change folder there, then went to a different folder on the hard disk. Let's go into utilities, watch it. See it flicker just a tiny little bit. It's super quick. One thing you could do with something like that is maybe stick, I don't know, 1 microfarad capacitor over the contacts there, so as it, you know, it flickers, it charges, and it might have a little bit more charge. I mean, it's so quick. I'm not even sure what difference that would make. I would assume it would just give you a little bit of a longer activity if there was a cap across there. Yeah, so the negative goes on this side here of the connector, but as you can see, you know, I can just plug and unplug that now. I've stuck a little red dot on the board there and a red dot on the side of the connector you can't quite see, just so I can remember which way around to reconnect that. So you can see, just for the moment, I've added some super small heat sinks to the main 4 chips actually, VIDC, the IOC down there, the MEM controller, MEMC down here, and the ARM. Now, I will get some larger heat sinks that better fit these chips, actually. They don't get super hot. I would say, in terms of ordering, the memory controller was the hottest after an hour of testing. VidC was second, then the IOC, then the ARM. The ARM was actually quite cool compared to everything else. Yeah, and the piddling little things, they're not really suitable. You want something that's going to, you know, fit the whole area of the top surface of the chip there. The next thing to do is deal with this. I didn't deal with this in the previous video here. Now I've had an inspection here, and it just looks like it just needs clipping on, so I think we just need to put a bit of brute force here. Did you hear that click? There we go. It's back together. And then just for good measure, crimp it in the middle. Can you see that went down in the middle there? Just because obviously it's come sort of slightly crimped, not crimped. There we go. So yeah, that should be good to reconnect now. You may want to disable the filtering stuff. I'll have a look at the schematics in a minute to show you what I mean. You would need to remove a couple of resistors that join the first stage of the op-amp stuff to the second stage where the filtering goes on, and then remove the caps on the output stage, and I think join from where the outputs come from the first stage, you know, straight to your outputs kind of thing. The problem there is you might be lacking some volume, because I think these two transistors here are used to, you know, increase the level there of the signal. And incidentally, when in part one, when I had a sound fault, one of the things I thought was it was going to be either a problem with the op-amp or a problem with one of those two transistors, or well, both of them, because I had no sound at all. The issue with the headphone jack, the reason I had no sound, I think there were two things. I sprayed some contact cleaner in there, and it seems to work okay ever since. But also, I don't know whether you saw that bit where in the first video where I was trying to enable the sound and it was crashing stuff. The CMOS was messing things up, and I don't know why, just occasionally when the CMOS got messed up, it seemed to affect the sound side of things. And I think at that particular point, that's when I was trying to test the cable. So yeah, there could have been some red herrings and things going on, but I did you know, have to spray some contact cleaner in there to make that a nice, good, reliable connection. But on the underside, the solder points are okay. And while we're here, before I forget, it might not be these two transistors, it could be these over here. There are a couple, you know, a pair of transistors, like BC239s or something. So yeah, don't take it for, you know, granted that these are the ones. They might be the ones down here. You need to have a look at the schematics, really. I mean, we're going to do that in a minute anyway, so that'll become clear then. The other option to get unfiltered audio is on PL2 here. Some of the pins here, as you'll see in the schematics in a minute, are unfiltered. So, you know, you could run a cable off and have a 3.5mm socket. I might try and do that just to do a comparison. I'm not sure how I'd feed it out. Ideally, I'd want to do it without modifying the back here, but we might just be able to squeeze a thin wire out there temporarily just to test it. I mean, I don't need to have the lid on, do I? I could just connect up a fly lead here and have a 3.5mm socket just for you to hear the difference, I guess. So in the last video, I had a bit of a ditzy moment, really, where I had no idea what this was, and if you think about it, it's pretty obvious. It is a fan controller, and these are thermocouples. I sort of wondered about that while I was editing, but as soon as people started posting comments saying, yeah, these are thermocouples, yeah, it kind of made sense. But even still, they're a bit bodgy, aren't they? You know, the way they're just in a bit of heat shrink here, and they kind of, I don't know if you can see, kind of, if you look in there, it almost looks like it was a pin, you know, a spade connector or something. It's really hard to see. So I'm guessing, you know, the idea is you mount the fan controller somewhere inside, and then maybe, I was thinking, feed one of those into the power supply there, actually. There's nothing exposed on it, so it should be alright. So the power supply is going to, obviously, you know, kick the thing into higher speed if need be, and then just have the other one on. I think someone suggested it goes on the hard disk, but we haven't got a hard disk, so I don't know, just stick it somewhere around the motherboard. But you could bypass it entirely and just have a full speed fan. So something else before I forget, this crazy thing here with the string, you know, again I was like having one of those ditzy moments. I was like, there's no way that could be factory, it can't be, etc. And it's not, obviously, but I think this was a kit, because I was getting deja vu flashbacks actually when I was looking at that, thinking I've seen string like that before, and I remember it was on an Archimedes previously. I think CPC in Preston used to sell a fan kit for these Archimedes machines. I don't know whether it was an optional thing or whether it was a replacement or what, and it came with a filter and it came with this string. It didn't come with bolts, because I have got recollections of fitting one of these myself, believe it or not. I remember following the instructions thinking, this is crazy, I can't believe they're mounting this with string. But that was what the kit comprised of. It may have had that piece of wood underneath as well, because it's got Velcro and everything, and it's stuck on the bottom of the fan there with Velcro. So yeah, I think this was a third-party fan kit, actually. So a quick look at the schematics here. You can see filtered, I think that says right, and unfiltered right. It's the same on the left, you can just about see up here. So you've got filtered and unfiltered. And if you follow the unfiltered all the way across here, it comes out the first stage of the op amp, and it's the same with the other channel. You've got these two op amps here, and the unfiltered you can tap off, and it comes out on the PL2 connector over here, so you can get unfiltered audio that way. But the point I was trying to make is it is unamplified. So I think some of the filtering is here. You've got resistors and caps and things here. So I think some of the filter stuff's in the middle, and you've got a second lot of these op amps here. It's one chip, but you've got 4 op amps in it. So you know the left channel goes through there, and the right channel goes through there. And then you've got these transistors here, the 239s, I think they are BC 239s on the output. So you've got that extra 2 levels of amplification there. That if you tap off the unfiltered, you're lacking that amplification. So there's a number of ways you could mod this. You could, you know, cut out some of these components in the middle, including that second op amp. Well, I don't know about that second op amp stage, because I don't think you can I don't think the op amps are actually doing the filtering. I think it's going to be the series of resistors and caps around there that are doing the filtering, probably. I could be wrong. Please correct me if you know more about that below. My understanding is these are just going to amplify. So you could, in theory, just cut all the stuff out in the middle and hop straight across, perhaps. And I think you'd probably get an amplified unfiltered that way. But I think my preferred way, if I revisit this and do a comparison in another video, might be to build a little amp circuit myself with an op amp and a couple of transistors, and tap into here and have an extra 3.5mm socket coming out the back somewhere. So I thought we'd cover a few other things here now. The apps icon down here, this is all coming straight from the ROM. So, you know, the operating system on these is all ROM based. That's primarily the reason these boot so blooming quick. You know, if you compare to, say, an Atari ST, yeah, you've got the TOS ROMs there on the Atari ST, and on the Amiga you've got Kickstart. But with the Amiga, you need to obviously boot from a Workbench disk to get into you know, a graphical user interface like this. Whereas there's a lot more ROMs on here. You've got 2 meg, you know, 4. You saw the 4 chips in the previous videos, and perhaps earlier in this video. 4 512K chips there with RISC OS 3.1 and 3.11. So yeah, all of this stuff is contained on ROM, so it's super quick booting. So the sort of things you get here, you know, you've got an alarm clock there. You can use that to set the time and date, which I've already done. A drawing application. Let's just launch that. And they all, you know, as you launch them, they all appear down here. You've got to click on them. So yeah, not dissimilar to the applications you get on some of those other systems there. Let's just quit that. Got a calculator, a text editor, the help. The help's quite interesting. You click on that and it shows you down here the actual help. Whatever you go over, it will tell you what it is, which is, yeah, that's really nice when you're getting used to the operating system here. It's nice touches like that that you don't tend to get in some of the other operating systems of the same era. Is that a character map thing? I presume it is, yeah. So you've got sorts of things you see in Windows 3 and Windows 3.11. Oh, that's a paint application as well. That seems to differ from the draw one. Yeah, so you can create sprites and things with that. Okay, let's close that. So you can obviously run things in parallel here, but it's kind of like, I think it works at a cooperative level. So that means if you're, you know, you run an app and that app just happens to be using 100% CPU, nothing else is going to happen. Everything else is going to be frozen in the background. You've got to write the application in such a way to free up, you know, resources, I guess. You know, not hog in tight loops and things with the CPU without, you know, thinking about the rest of the system. If you're writing an application that you want to use on the desktop here and run with other applications at the same time, you need to think about that. So yeah, I mean, once or twice I found an application could lock up and the whole thing will freeze as a result until that application finishes doing what it's doing. If we're going to configure, the other thing I was going to show you here, let's just close help, is what you get in here. So obviously you've seen the disks thing where you add hard disks and things, mouse settings, so you can change the speed, the double click delay, etc., and the distance, keyboard. So yeah, again, you know, it's the repeat time and the delay for each key, so you can alter that. The memory settings, so you can specify how much memory is assigned to each of these things as well. And you can, I think you can configure that sort of stuff in the boot side of things as well. I'll perhaps show you that in a second. Sound you've already seen, printer, no, I'm not going to go into those. Applications, that's just the stuff that's on the ROM basically. You can tick these to say which one of these you want to automatically start on boot. So that's a nice feature, especially with the alarm clock and stuff like that. But the one thing I've been using in here is the screen option. So as you can see, we've got a few different settings and things, and you can go normal, VGA, super VGA, and then you've got multi-scan, high-res mono, LCD. What was I going to say here? Yeah, so if we choose, where's it gone, interlace, just watch this. Look how much crisper that is. Now you can see the actual pixels individually. They're not kind of blurry as they were in a non-interlace mode, and it's rock solid. I'm amazed at how sharp that is. I'm tempted to leave it on that, but I do quite like, if you just watch the difference when I click that, put it back into the normal. I suspect actually that this is interlace mode. I think maybe that's the inverse. I don't know. Please post below what you think's going on there. I suspect that's not interlaced, and when you click it, that is interlaced. Could be wrong. Although that's on automatic mode selection there, which is interesting. So I don't know. It's just curious. Anyway, you've got lots of different options there. You can change the blank delay, the vertical screen mode, the vertical adjust. That's quite good. Let's just try playing with that a little bit. Yeah, you can see it going down off the screen now. Can you see that? That's really nice. Not many operating systems give you that ability built in. And you can go the other way as well. That's sweet. I really like that. Anyway, put it back on the default. So in a previous video there, you could see I swapped out these missing screws here for some gold top ones, but they had like a fixed washer on the head there, and that wasn't correct. You know, it was catching on the tops of the and the bottom of the lip there. So I ordered some brand new, I think these are M3 bolts actually. They're just the same size as these original ones. They're slightly longer, but they're the same in terms of the thread. I have thoroughly enjoyed working on this Archimedes. It has been a joy to work on actually. Bear in mind, there wasn't really very much wrong with it. You know, there was a bit of leakage around the battery area there. Initially we didn't have sound, but that was just because some things had been disconnected. The hard disk, we had to swap out the compact flash card, but I think that was worth doing. In future I'll probably revisit this to do some more videos. I'd like to recap this at some point and maybe think of some other expansions or mods I could do to this. I might revisit the audio side of things there. You know, you saw I fitted that little Burr Brown op-amp chip there. I didn't do any captures of the unfiltered audio. It's so low level because you've not got the transistors there. And the reason I didn't completely mod the audio side there to get rid of that filtering is it's a kind of a characteristic. You know, these had a really good sort of low bassy sort of sound to them. It's, you know, they were really super well filtered, you know, so you don't get any noise or anything. But yeah, you do lose some of the high frequency sound there, but that's a characteristic of this system. It's a bit like modifying a C64 to get rid of the filter on the SID. You wouldn't do it. You wouldn't. You know, it's one of the characteristics of how it sounds. The ARM RISC chips that are inside these went on to become a global phenomenon. Really, you know, it's like they're in everything. They're in absolutely everything. You know, I don't know, washing machines, mobile phones, tablets, computers of various types. You know, they're just used all over the place. ARM processors. And echoing again what I said in the BBC, you know, they inspired millions of people, myself included. I got into the industry because of my exposure to the Acorn BBC Model B. Yes, I've stuck it on the back plane there, in posturum. I can't even say it, I don't think. That means the future. I think what I put on the back of the BBC there was towards better things. I forget what this Latin was for that. But yeah, you know, with it being an educational thing, you know, these were used primarily in the educational sector here in the UK. I'm sure there were lots of businesses in the scientific area of things where perhaps they used the Archimedes, but it was primarily sold to schools and stuff and colleges and universities. So I do hope you enjoyed the video. If you can think of any other upgrades and mods and things I could do to this, please let me know in the comments below. Please like, share and subscribe, and I'll catch you in the next video.